Okay, welcome to electrical machine lecture. Today we are going to discuss DC motor characteristic, losses and efficiency. So the first part is the DC motor characteristic. So to know the characteristic of motor is very important because based on the characteristic, the application of motor is going to decide. Either it is a constant speed motor, constant torque motor, or the speed decreases with increase in load. These are some parameters which decide the application of DC motor. Now the DC motor has wide application and this application is based on characteristic of motor. Now the DC motors are classified into the DC series motor, shunt motor, separately excited motor and compound motor. So to know the characteristic, there are three major characteristics are there. One is the torque armature current characteristic. This characteristic is going to plot between the torque of armature versus armature current. Therefore, it is a torque armature characteristic. Second characteristic is the speed armature characteristic. It will give the relation between speed of motor versus armature current, or indirectly it is a load current because the armature current is the function of load. So either if the motor is loaded, the armature current will be more, and if the motor is under no load condition or light load condition, the armature current will be small. And third is the from these two, it is possible to know the speed torque characteristic of the motor. Now to know the characteristic or to drive the characteristic of any type of motor, DC series, shunt or compound motor, we know that the torque and armature relation, similarly speed and flux relation. So the torque armature torque is directly proportional to flux per pole multiplied by the armature current. So this is one relation, it is very important. Now the second relation is that speed is directly proportional to back EMF and inversely proportional to flux. So that speed n we can write as speed n is directly proportional to back EMF. So it is V minus IA RA, whereas the flux which is produced by the field winding, so we write as a field winding IF. This field winding current may be the series field current, may be the shunt field current, or it may be the combination of shunt and series for the DC compound motor. Now here the speed is directly proportional to back EMF. So as long as the flux is constant, say for example DC shunt motor, the speed is simply directly proportional to back EMF. And if we are keeping the terminal voltage is constant and armature current is constant, the speed is inversely proportional to the field current or field flux. So now based on these two basic equation, torque is directly proportional to flux and armature current. We will take the DC series motor. So for the DC series motor, first we will draw the diagram for the DC series motor. DC series motor where the series field winding and shunt field windings both are series field winding and armature winding both are in same phase. So it is series field winding having few number of turns as it is connected in series and it carries the full load of the motor. So this is the simple diagram of DC series motor. So now in case of DC series motor, armature current and field current is same. So we can write as this is the load current, the current which is flowing in the series field winding is IF, and armature current all are in series. So it is the same. So we can say that as as armature torque TA is directly proportional to flux into armature current. Since flux is directly proportional to field current IF, where for series motor IA is equal to field current. So we can say that torque TA is directly proportional to IA into IA, where torque is armature torque is directly proportional to square of current. So as long as the field is unsaturated, the armature current is proportional, field current, flux is proportional to the armature current or field current, and hence torque is directly proportional to square of current. So as it is square of current, this relation, so it is possible to draw the torque characteristic, and the speed characteristic. Now the torque is directly proportional to square of current. As it is square of current, it will give such type of characteristic DC series. So it is a torque and this is armature current. So at a small value of current, the square value of this one will be small, but as soon as the current magnitude increases some appreciable value, the square of that current, the square of that value will be more, and hence it will give such type of characteristic. And as we know that it is a DC series motor, so at even no load condition, the armature current having non-zero value. So this is going to plot it. This is the non-zero value because the difference of these two is nothing but the torque loss. So armature torque TA minus TSH is the loss torque. So it is the loss torque. So the difference of these two value is nothing but the loss of torque because of the rotational or windage and frictional losses. So this is the armature torque and it is smaller for the same value of current is the shaft torque. Now similarly, as speed is directly proportional to back EMF, speed is, say here, speed is directly proportional to V minus IARA divided by the flux, or it is the shunt field. It is, for here we can write as uh, speed is directly proportional to V minus IARA divided by the armature current. Why it is armature current? Because flux is directly proportional to field, and here armature current and field current is same. So it is quite clear that the armature current is in denominator. As the load increases, which is load increases, the current, armature current also increases, and hence the speed decreases. So there is a drastic change in speed from no load condition. Say this is the no load speed. So speed is very high at no load condition, I0, and whereas if the motor is loaded to the full load condition IF, or so IFL, full load condition, so the speed of the motor is decreases. So it is called as a inverse. Speed is the inverse characteristic, means armature current increases, speed decreases with a sharp value. Now one more thing, the DC series motor never started at no load condition, means we have to put some of the load on the motor, otherwise the speed of the motor increases infinitely. Theoretically, means the speed of the motor is continuously increasing, and because of continuous increase in the speed, the motor come out from the foundation, or it will give the very large centrifugal force. So the DC series motor is always started by some sort of a small light load over the motor. Say this type of question many time asked in the interview or some say practical examination, as well as some objective type questions also. So this is the inverse characteristic. This inverse characteristic is very much useful for the railway traction, as the torque is directly proportional to square of current. So it will provide the high starting torque, and speed decreases when it increase in the load. So it is called as a self-relieving property of the DC series motor. Means if the suddenly the load increases of the DC series motor, or motor get overloaded, it does not draw large current, whereas it speed decreases. So it avoid the failure of motor also. So these type of characteristic is more suitable for the railway traction. It may be hoist, crane, and sometimes we are using DC series motor or universal motor which operate on AC as well as DC, because the universal motor characteristic also the same, and it is used in the mixers also, domestic application. Now from these two characteristic, it is possible to know the characteristic which related to the speed and torque. So if the torque increases, the increase in torque is going to observe at the higher value of current. So at higher value of current, the speed decreases. So it will give the same characteristic for the DC series motor. So this is the some brief say uh, the DC series motor, characteristic of DC series motor. Now we will consider DC shunt motor. So here the back EMF, we can write the equation again. It is the speed N is directly proportional to V minus IARA divided by flux phi, and speed is inversely proportional to field current or armature current, IARA divided by armature current. Now for the DC shunt motor. Now first it is draw. We will draw the DC shunt motor. DC shunt motor. So here shunt field winding in parallel with the armature. So DC motor, shunt field current ISH. Here is the supply voltage V, and it is, sorry, this is the armature current IA, and this is RSH. So current is equal to ISH, and this is load current I, or motor drawn the load current. Now same armature torque, first relation is directly proportional to flux into armature current. Now here flux phi is constant as long as supply voltage is constant. Voltage is constant. So we can say that therefore armature torque TA is directly proportional to armature current. So this is the relation. Armature torque is directly proportional to the only armature current. Similarly, speed N is directly proportional to back EMF and inversely proportional to flux. And for the DC shunt motor, speed is N is directly proportional to the V minus IA RA, that is the back EMF, since the flux is constant. So now see, torque is directly proportional to armature current. So it is a linear relation. So for this really linear relation, this is the torque for the DC shunt motor, and this is armature current. So it will give the linear torque, armature torque. At armature current is equal to 0. So definitely the current is 0. So the torque is 0. And as the armature current increases due to increase in load, when we are increasing the load on the torque on the motor, so the torque also increases with a linear relation. But as we discussed in the DC generator, there is a armature reaction. So similar armature reaction also occurred in the DC shunt motor. So because of this armature reaction, the flux over the periphery get decreases. So because decrease in the flux at higher load condition, the armature reaction is going to observe at higher load condition. So slightly the torque also decreases. This is because of the armature reaction. This is because of the armature reaction, and it shows the difference of these two value is nothing but the loss torque loss due to the windage and frictional losses, and this is the shaft torque. Now speed. For the speed of the motor, when the flux is constant, speed is directly proportional to the armature, directly proportional to the back EMF. Now where the back EMF is V minus IaRa, where armature resistance is very small, say for example, supply voltage is 400 volt, whereas the armature current is 50 ampere and armature resistance is 0.1 ohm. So as compared to the rated voltage, the voltage drop across the armature resistance is very small, is a very small. It means that the speed drop in the DC shunt motor is very less, and therefore it is going to observe this is the no load speed at no load condition, say for example 1500 rpm. But as soon as the loaded motor is loaded, the voltage is going to drop across the armature because of the armature resistance, because of the brushes, and because of the say because of these two reason, the uh, back EMF V minus IaRa also get decreases, and it will observe that the speed of the motor decreases, but that decrease in speed is very small, say for 1500 rpm at no load condition, and it is 1460 rpm or 1470 rpm. So this is the drop in speed, and this is the characteristic. So we can say that it will give the moderate torque, means the torque is constant and the speed also constant. So the DC shunt motor find the application where speed is required is constant. Say for example, printing machine, it may be a lathe machine, it may be a pump, and many application where speed we need a constant, then it is possible to use the DC shunt motor. Nowadays, the DC shunt motor or permanent magnet DC motor is widely used in many applications. The one reason is that the DC shunt motor speed or DC motor speed can be controlled very easily as compared to the three-phase induction motor. So that's why where wide range of application, wide range of speed application is needed, DC shunt motor is more suitable as compared to the AC motor. Now, from this one, there is a slight decrease in speed. So here the torque also get decreases. Torque also get decreases with respect to the uh, sorry, speed is decreases with respect to the torque. Torque increase over the motor. Now, compound motor. So the compound motor is in such a way that it has a two type. One is the cumulative compound. First is the cumulative compound motor, and second is differential compound motor. Now, in case of cumulative compound motor, when the flux produced by shunt field winding 5sh, and the current and the flux produced by series field windings both are in same direction, then the total flux phi t is equal to phi sh plus phi se, and it is called as a cumulative compound motor. Okay, so we will write this point somewhere here. So this is the phi t, flux phi t is equal to phi sh plus phi se, and it is called as a cumulative compound. Okay, now when the flux phi t, total flux, is equal to phi sh minus phi se, then it is called as a differential compound motor. So the things already explained in the DC generator. Now we know that the relation of torque TA is directly proportional to flux produced by the field winding produced by the field winding and armature current. So for the cumulative compound motor, as load increases, DC shunt winding is remain constant, only the share of series field winding get increases. Shunt field flux is constant because irrespective of the load condition, the current in the shunt field winding is constant, as we have seen in the DC shunt motor. Whereas the series field flux, which is connected in series with the armature, the flux get increases. So there is a slight increase in flux. When there is an increase in flux, the torque also get increases. Now the DC compound motor is dominantly shunt motor. It means that the effect of shunt field winding is more as compared to the series field winding. So basically DC compound motor is a DC shunt motor. Only few turns, these few turns are added in the field winding. Either it is going to add the flux or either it is going to subtract. So therefore, for that purpose, we will draw the characteristic of DC shunt motor as a base characteristic. So this is the linear characteristic already discussed. This is the characteristic of DC shunt motor. So it is TA and it is shunt motor. Yes. Now as load increases, series field flux also increases. Therefore, the total flux will be somewhat more than the previous value, and hence the torque increases. So we will find the increase in torque at a small value of load. The flux created by the series field winding is not much more influence over the shunt field winding, but the load current is appreciably high, then the flux created by the series field winding will be definitely more, and it is going to observe at higher load condition. So here the torque increases, and this increase in torque, similar to the DC series motor, it is for the cumulative motor. So it is TA for cumulative motor. Okay. Now opposite to this one, if it is differential motor, where the total flux is the difference of these two value, as the load increases, the share of series field flux also increases, but it is in opposite direction. It is in opposite direction phi se, and hence the total flux decreases, therefore the torque also decreases. So this is the decrease in torque is going to observe. So this is armature torque for differential motor, for differential motor. So it is somewhat clear. So here the torque is directly proportional to flux into armature current. Now take the, this is for the armature torque. This is torque TA and it is armature current. So this is the relation. Now similarly, this is speed in RPM, and this is armature current. So torque armature current and speed armature current. Now again we will draw the characteristic of DC shunt motor. We know that the DC shunt motor is a somewhat constant speed motor. It is a constant speed motor. So this is the speed of DC shunt motor. For our simplicity, we consider this is the speed of DC shunt motor. Now, as load increases, the flux also increases, and we know that speed is, as long as the back EMF is constant, is EB upon flux phi. So for the increase in load, the flux is additive. The flux, it is in denominator, so speed decreases. So we will observe that there is a decrease in speed, and this decrease in speed is for the cumulative motor. Whereas for the differential motor, the flux is difference of these two value. So as the total flux over the periphery is smaller, therefore the speed will be more. So here the speed will be increases. So as load increases, after some time, the speed of motor also increases. So here speed for the differential motor. So this is the characteristic of DC compound motor, which is the combination of DC shunt motor as well as DC series motor. But dominant characteristic is the shunt motor characteristic, and a small effect is going to observed in the DC series motor characteristic. Now, based on this characteristic, we will summarize the characteristic versus some application. Type of motor is a DC shunt motor. Speed is fairly constant and medium starting torque. It does not provide the DC shunt motor does not provide high starting torque. Now, for our simplicity, we will draw the characteristic in this block itself. So this is the armature current. This is armature torque, speed, armature current. So torque is constant. So starting torque is not much more, whereas the speed is somewhat constant, and there is a speed drop we are going to observe, but it is fairly constant speed motor and medium starting torque. It is used for the blowers and fans. It is used in the industry uh, where the fans and blowers are there, centrifugal pump and reciprocating pump, lathe machine where the constant speed is needed, machines, tools, many machine tools which is required, like a drilling machine, milling machines. So here drilling machine, milling machine where the constant speed is needed, we can use the DC shunt motor. Now second is the DC series motor. The series motor, the important characteristic is that armature and torque is higher, means it is the square of current. So at a small value of current also, the value of torque will be more as compared to the DC shunt motor. The DC shunt motor torque is directly proportional to current and speed is directly proportional to only EB. Let, for example, the starting current is 10 ampere, the torque will be 10 Newton meter, say. Whereas if the starting current of DC series motor is 10 ampere, the starting torque will be square of current, that is 100 Newton meter. So we can say that the starting torque of DC series motor is large. So high starting torque, it provides the high starting torque. no load condition is dangerous because the speed of the DC series motor increases with respect to the, means as the load is small, the speed of the motor increases dangerously. So DC series motor never started without load and variable speed. As load increases, the speed decreases. But such type of characteristics is more suitable for various application like crane, hoist, elevators, trolley, conveyor, and electric locomotives. So for the electric traction, most suitable motor is the DC series motor, where high starting torque is needed. The speed drops without increasing the appreciable amount of armature current. Now, third is the cumulative compound motor. Higher starting torque. The reason is that torque is directly proportional to flux into armature current, and no load condition is allowed. Here, whatever the say limitations is there in the DC series motor, but that limitation is going to overcome because it is not a completely DC series motor. It is the combination of shunt and series. As the speed of the DC cumulative compound motor is almost constant, so it is used for the rolling machine, punch machine, shearing, heavy planer, and elevators. Whereas the differential compound motor, the speed increases, we do not find much more application, engineering application, where the speed want to increase continuously with increase in load. So these are the some brief introduction to the application also, but it find very large application. Nowadays, we are using a brushless DC motor instead of brushes. It is a brushless DC motor, and brushless DC motor is more popular nowadays. In case of the DC microgrid, and DC microgrid is going to uh, find much more application in the DC appliances, where as we know that mostly all appliances nowadays we are using the DC application, like your LED lamp. Now we are using BLDC fan instead of the regular fan. We are using brushless DC motor fan whose power consumption is hardly 27 or 28 watt as compared to the 60 or 70 watt of our regular fan. Similarly, our lamps are the now LED lamp which is going to work on the DC, our laptop, computers. So nowadays, because of this more and more small application, household application moving toward the DC supply. So DC microgrid is more popular. And why it is more popular? Because of the BLDC motor, brushless DC motor, or permanent magnet motors. So like in electric vehicles, we are going to use DC motor, brushless DC motor. We are using charging station. Again, it is a DC supply. It is going to work on the DC motor, so there is no conversion is needed from DC to AC. So therefore, DC BLDC motor, brushless BLDC motor, brushless DC motor find the application in electric vehicles. Similarly, in industries, because permanent magnet, the iron losses and the copper losses in the stator winding is going to reduce. So the efficiency of brushless DC motor or the permanent magnet motor is more as compared to the conventional or an standard three-phase induction motor. So many applications are available in the industry. Similarly, in the water pumps, submersible pump, or it may be a like a, uh, solar pumps are available. That solar pump is going to work on the DC supply. So for the field where the supply voltage is not available, your grid supply is not available, we can mount some 4 or 6 module, PV module, and the pumps are there. Similarly, drones, many small applications are there. Household application like BLDC fans, it may be a vacuum cleaners, or other applications it needed computer, laptops. These are also needed the DC supply. And it's like printer, and where the constant speed and without say sound, many medical applications we need the we find the application of DC motors. So this is the today's lecture based on characteristic of DC series motor, and from the characteristic of DC series motor we find application of DC motors in the different application. Thank you.